Today's lesson is titled Areas of Circles and Sectors. So the area of a circle, you guys told me just a little bit ago that the area is pi r squared, but do you know why? Or do you have a good way to remember why? A geometric way to remember why? No? Well, our book suggests that we actually take a cardboard or construction paper circle like this and cut it on the 4 dashed lines. So if we did that, what would we have? Four parts of a circle, right? Kind of triangular shaped, sort of, but they're curved on the one edge. So we'd have 4 shapes that look like this next one, and then they suggest that we cut those into little pieces that are the same size, if possible. So could you imagine doing that? But could you do that? I mean, it'd take time, but it'd be time consuming. It could be done, right? A third grader could do it, probably. Especially if you drew out the lines for them, they could cut it along there. And then what if we did that with all 4 sections and then lined them up like this? What shape is that circle starting to get close to when we cut it apart and line them? Kind of a parallelogram, yeah. Kind of a parallelogram. What if we made these wedges narrower, not so wide? What would start happening to the sides, these vertical sides? They start getting really straight up and down, right? The narrower we make the wedges, the closer this thing gets to a rectangle, right? So if we just kept cutting this and making it smaller and smaller and smaller and smaller, pretty soon you couldn't be able to tell the difference between a rectangle, and pretty soon the edges would look flat too instead of having these little bumps. So if we did that, what would this distance here be? The vertical distance on the side is what part of the circle? The radius. Yeah, that's the radius. And now we got to figure out what this distance is. This along the top or the bottom, the width. The width would be equal to what part of the circle? Yeah, he said it's half the outside, half the circumference, because there's going to be half on top and there's going to be a half on the bottom. Do you agree with that? Be half of that. But right here, they're just calling that B. But let's play with that for a little bit and see if we can figure out what that is. What's the circumference again? We just did a problem that had us use circumference. How do you find circumference? Anybody? 2 pi r. And you said that this B value would equal half of that, right? Because we'd have half the circumference along the bottom and half the circumference along the top. What's half of, well, let's keep going. What's half of 2 pi r? What's half of 2? 1. So this B value is the same as pi r. So B is the same as pi times r. How do you find the area of a rectangle? Base times height, length times width. So that would be pi r times r, which is the same as what? What's r times r? Same as pi r squared. So there's the area formula for a circle that we've learned in previous classes, but we can see where it comes from in a geometric sense here. The people that wrote our book are pretty smart. All right, let's move on here. So most of the time what you just see is you get the theorem or you get the formula. The area of a circle is the product of pi and the square of the radius, r. So we know area equals pi r squared. And sometimes we confuse that with circumference, but if you just remember that area has to be a square unit, you'll remember there's a square in the formula. Circumference has to be a linear unit, so there's not going to be a square in the formula. All right, this gets us into sectors. A sector of a circle is a region bounded by an arc, in this case xy, of the circle, and the 2 radii, xo and yo, to the arc's endpoints. So a sector of a circle, if you just think of a slice of pie or a slice of pizza, you're basically looking at a sector of a circle. That's a classic example. You can name a sector using one arc endpoint the center of the circle and the other arcane point. In other words, you can say y, o, x, or you can say x, o, y, kind of like you're naming an angle. But you can't say it's y, x, o. O can't be the last letter or the first letter. It has to be the middle letter. The slice of pizza at the left is sector x, o, y of circle O. So these are sectors, and we can find areas of them too. This should make sense. If we can find the area of the whole circle, which we can, pi r squared, can we find the area of a fractional part of it? Doesn't it make sense just to take the fractional part, the measure of the arc, divided by 360, that'll give us the fractional part that this takes up for the whole circle, times the whole area of pi r squared. So it's kind of like when we were doing arc lengths last week. We just take the fractional part of the circle times the circumference, 2 pi r. And we find out what fractional part of the whole circumference we're getting. Here we're just finding out what fractional part of the whole area we're getting. The measure of the arc could also be the measure of this central angle, right? Yeah, it's done. Yeah, it's done. Find the area of a sector ZOM. Leave your answer in terms of pi. So let's find the area of this thing. Area equals what? What? How do we do that? Am I finding the area of the whole circle? No. But I know the area of the whole circle is 2 times what? Or is it 2 times? What is the area of the whole circle? Yeah, it's pi times r squared. So it's pi times 20 squared. That's the area of the whole circle. But I'm not finding the whole circle. I'm finding just a fractional part. What fractional part? What fraction do I need to put here? Which is 72 degrees. Over how many total degrees would there be? 360. So I'm just looking at the 72 over 360 fractional part. I'm not looking at the whole area. So let's see, 72 over 360, what does that become? Isn't 36 going to both numbers? Let's pull this over to the side. 72 over 360. How many times does 36 go into 72? Twice. How many times does 36 go into 360? 10. So that's going to reduce down to 1/5. So 1/5 times, what's 20 squared? 400 times pi. How many times does 5 go into 40? 8. So how many times does 5 go into 400? 80. So it looks like we're getting 80 pi. What's our unit? Square centimeters. Good. Is this an exact answer or an approximate answer? Did we round anywhere? Yeah, it's an exact answer, exactly. I like the way you said that. It's an exact pi answer. That's exactly what it is. They got the same answer. The area of sector ZOM is 80 pi centimeters squared, or square centimeters.